The purpose of this video is to help when you have types of linear inequalities and you have to graph them. Now, these are the more basic style when you have your linear inequalities that are set to y equals mx plus b form. We remember that's the slope-intercept form or a linear equation where m is your slope and b is your y-intercept. So we are going to use this equation, this linear equation, slope-intercept form, as a way to find how to graph linear inequalities. So the only thing different than this from the linear equations is the inequalities that are involved and how you will use those inequalities to show different style graphs. But before we begin, we need to make sure we understand what the inequalities do or how we use the inequalities that are given to us. So I like to break these up and talk about the two different types, the greater thans and the less thans, and what type of line and shading you will have. And it'll make more sense once you see the actual equations or inequalities being graphed. It will make more sense. But when you have linear inequalities that have a greater than or equal to or greater than inequality, you'll see exactly what you'll need to do. So if you have a greater than or equal to inequality, so it'll be y is greater than or equal to 4x plus 3, something along those lines. But the inequality is greater than or equal to. Once you determine what the slope is, once you determine what the y-intercept is, you'll have to graph the inequality. And the type of line and the shading that you have depends on what the inequality is. So if you have one that is greater than or equal to, if it's greater than or equal to, it will have a solid line. And what I mean by a solid line, it's just a normal line that you would have used with y equals mx plus b when you graph the line. And all this means is that any point on the graphed line can also be a solution to the linear inequality. Also with it being greater than, and again, this will make more sense when I get to the actual process. All of these you will shade above the line. So you'll be shading above the line when it comes to graphing these linear inequalities with greater than or equal to. If it's greater than, the difference would be you're using a dashed line, but you will still be shading above. So everything that is greater than, you will be shading above, but if it's greater than or equal to, you will have a solid line, and if it's just greater than, it will be a dashed line. So you will be using this when you have linear inequalities that are greater than. So let's go to the less thans. Now, the type of line does not change. As long as the line is equal to, it's going to have a solid line. Same thing with less than, just like it was for greater than, it's going to have a dashed line. So if the inequality is equal to, it will be a solid line. If it's not equal to, it will be a dashed line. Now, if you shade above for an inequality that's greater than, you probably already figured out that if you have a line that is less than or equal to, you will shade below the line. And if it's less than, you'll still shade below the line. And hopefully this will make sense as we go through the examples. So just remember that if it's equal to, it's going to be a solid line. If it's not equal to, it's going to be a dashed line. And if either one of them is greater than, you'll shade above the line. And if either of them are less than, you'll shade below the line. But the best way to go through this is actually to show you examples of that. And we're going to go through the first example. So the example that I have is y is less than or equal to negative 3 over 2x minus 5. Still using the y equals mx plus b form, we're trying to find the slope and the y-intercept. Now we know the slope is the m value and is in front of x. The y-intercept is the b value. It follows x in this case. So in the linear inequality that's given to us, we know that our slope is negative 3 over 2. We know that our y-intercept is negative 5. And we also have the inequality of less than or equal to. So if the inequality is less than or equal to, you know it's going to have a solid line and it's going to be shaded below that line. So I'll show you what I mean by that. First thing we have to deal with is the y-intercept. We know that our y-intercept will always be on the y-axis, and since its y-intercept is negative 5, that's where we'll put our first point at negative 5 on the y-axis. Now, our slope is negative 3 over 2, which I always attach the negative with the top number, which is down 3 and right 2. So our slope would be, we would go down 3 and right 2 from our starting point. But if you look at our starting point of negative 5, which is our y-intercept, we can't go down on this graph because we only have one unit down. So if you can't go down and right, just do the opposite. Go up and left. So all you're doing is, instead of making it negative 3 over 2, you're making 3 over negative 2. Just go the opposite direction. So we're going to go up 3 because you want to do the rise first. 1, 2, 3, and left 2. 1, 2. And there is our second point. And we could continue that all the way through. Up 3, 1, 2, 3, left 2, 1, 2. And you will be able to see that the line is already showing itself throughout the graph following the slope. So again, our slope, we went up 3, left 2 because we could not go down 3, right 2. You just do the opposite of both. So once you have your point or points, you can draw your line, and this is an equal to. This one is less than or equal to, so it's going to be a solid line. So I'm going to draw a solid line on my graph. You still want to put the arrows at the end because this goes on indefinitely. There is no stop to it just because the graph stops. And since it is a less than inequality, you want to shade below that line. So and the way I determine if you go above or below, I choose a point anywhere on the graph, which in this case I'm going to choose right here at negative 2, 2. So I know that that's a point on the graph. So I either choose below or above. If it's below that point, it's a less than. If it's above that point, it's greater than. We know that it's a less than inequality. So from that point, I'm just going to shade everything below the line using the line as a boundary. And what the shaded area represents is every possible solution for the inequality of y is less than or equal to negative 3 over 2x minus 5. So this is an example of when you have a linear inequality that is less than or equal to. Let's go to our next example. Our next example is y is greater than or equal to negative 3 over 2x plus 2. So again, we're trying to identify our slope. We're trying to identify our y-intercept. And we see that our slope, which is always in front of x, is negative 2. But we want to make our slope a fraction, so we'd make it negative 2 over 1. The way you make a whole number a fraction is you just place it over the number 1. Our y-intercept always follows x. In this case, it's positive 2. And we also have the inequality of greater than or equal to. We remember that everything that's equal to will always have a solid line. And since this one is greater than, you're going to shade above that graphed line. So in this case, we will go to positive 2 on the y-axis because that is our y-intercept. And remember, the y-intercept will always find itself on the y-axis. And since it's positive 2, we go to positive 2. Now our slope is negative 2 over 1, which means we're going to go down 2, right 1, which we can do that. We will go down 2, 1, 2, and right 1. And remember, when you graph the linear equation or the linear inequality, you will always start at the y-intercept. People make the mistake and start at the origin. You don't want to do that. You want to start at the y-intercept. In this case, it was positive 2. Since we have 2 points, that's all you really need in order to graph a line is 2 points. We know that this is greater than or equal to, so since it's equal to, it's a solid line. So we're going to draw with a straight edge our solid line all the way through. But this time we see that it is a greater than or equal to, so we'll go to any point. In this case, I'll go to the y-intercept of positive 2, so at 0, positive 2. And I know it's greater than, so I know everything above that point will be shaded. So I will just go along the line there to shade everything that is in this linear inequality. So now the shaded area represents all of the points that would solve for the linear inequality of y is greater than or equal to negative 2x plus 2. So you graph the line just as you normally would using slope-intercept form, and then you use a solid or dashed line based off of what the inequality tells you, and then you shade above or below. Since this problem was greater than or equal to, our line was solid, and we shaded above the line to show all of our possible answers. Now we have a problem that is y is greater than x plus 3. So I always tell my students, if you have a y and you have an x, then you have a line that has a slope. I always tell them if there is no x, there is no slope, so you have a flat line. But in this case, we do have a slope because we have an x. And if you have the variable x, or you have any variable in an equation, in an inequality, no matter how it's set up, there will always be a coefficient to go along with that variable. In this case, the coefficient is and the definition of a coefficient is the number that multiplies into a variable, or the number that's attached to a variable, the number that's in front of a variable. So in this case, we know that our coefficient is going to be 1 because there's only one x there, which means our slope would be 1, and as a fraction would be 1 over 1, which again would just mean we go up 1 and right 1. Our y-intercept is always going to follow the x, or not attached to the x. In this case, it's plus 3, which tells us that our y-intercept is positive 3. So on our y-axis, our y-intercept is going to be positive 3. Now we have the inequality of greater than. Now we just did greater than or equal to, so we know we're going to shade above. But in this case, where it is greater than or equal to, this one is just greater than, we know that we're going to use a dashed line, meaning that any answer that falls on that dashed line cannot be a solution. So dashed line means the line is not a solution. A solid line means the line is a solution. But from here, we want to graph, and we have a slope of up 1, right 1, and if we would go up 1, right 1, you would see our point, and that would go on. You can extend that as far as you need to do it. So I'm going to draw my line through those points and extend it through the graph. Oh, and don't make the mistake that I did. It's a dashed line, so make sure you make a dashed line if it's not equal to. So since this one is greater than, it's going to be a dashed line. Equal to is a solid line, greater than is a dashed line. And since this one is greater than, we are going to take a point, which I'm going to use the y-axis, or the y-intercept. On the y-axis, greater than means above, and I'm going to shade everything above the line. Don't make the mistake of shading left or right of the line, because that sometimes will not be correct. Make sure you shade above or below based on the inequality being greater than or less than. One final example that you may see is a linear inequality that has no y. So there's no y variable on this. So if I tell my students, if there is no y, the slope is undefined. And if you remember that an undefined slope is a line that goes straight up and down, not left and right. A slope is determined by how much the line goes up and down as it goes left to right, the rise over the run. But in this case, since there is no y, you're not going to be using the y-intercept. You just have x is less than or equal to 1. Meaning we are going to use the y-axis in this problem because there is no y. Again, no y means we're not going to use the y-axis. We're going to use the x-axis, and we're going to mark our first point at +1 on the y-axis, and then we are going to draw our solid line because, again, it's equal to on our coordinate plane. So now we have the line drawn for this inequality. Now there's always a lot of confusion when this happens because there is no above or below the line. So I tell my students to think of it as a number line. Use the y-axis as a number line. So if the inequality says y is less than or equal to 1, you need to represent every number that is less than or equal to the number 1. And if you look at the y-axis, you will see that all of the numbers that are smaller than 1 are left of the line or left of the +1. So that is what you will shade. So the only time that you will actually do left or right is when you have the variable that comes first and there is no x variable. There is no y variable. It only has x. And in this case, it was x is less than or equal to 1, which meant a solid line on the coordinate plane, straight up and down, undefined, and everything left of that line is going to be shaded to show the possible solutions. Hopefully this makes sense and it's clear for you, but if you have any questions, feel free to message me, let me know, and I will try to answer any way I can. Hope this helps.